You're listening to Coding Blocks Community Talks. Be sure to like and subscribe and find more developer conversations at codingblocks.net. We've got a variety of experience levels here today, so we're going to ask some questions and bounce some questions around to see what happens. But before we do, let's find out a little bit about our panel. Start with Aaron.
Hi, I'm Aaron Clawson. You'll see me as Mad Viking God. I've been working with Kubernetes for about a year now, and I've been doing Docker on the side for at least 3 or 4 years. So quite a long history with these tools.
Awesome. I'm Alan Underwood. I'm co-host of Coding Blocks. I have a pretty decent amount of experience with Docker and brand new to Kubernetes, so really looking forward to this one. Jessica, that's you.
Hi, I'm Jessica Groot. I'm a web developer. I have no experience with Docker and Kubernetes.
All right, I'm Joe Zack or Zack, depending on the day and my mood. And I've got a little bit of experience with Docker, mainly in the kind of open source like projects. So, basically nothing. And then I got a nice little walkthrough on Kubernetes from Aaron here. So I'm here trying to learn.
I'm Michael Outlaw. I'm another one of the co-hosts from Coding Blocks. I have some what I would call hobbyist level experience with Docker. Nothing in production yet, and so that's why I say that. But Kubernetes is new to me as well.
Russ, you're up.
I'm Russ Hammet, just a developer, probably pretty close to Michael, it sounds like. I've played around a little bit with Docker, but no experience with Kubernetes.
Paul.
Hello, I'm Paul Spoon, aka Spoonraker in the Slack group. I have a pretty good amount of knowledge of Docker. I've, spoken about it, even though I don't have much actual experience using it at work. And as far as Kubernetes is concerned, I have read the documentation for at least 5 minutes.
I'm Sean Martz. I'm a software consultant. I believe that the faster you fall behind, the more time you have to catch up. I've used Docker in my local dev environment to run SQL Server on a Mac, but very much a manual process, spinning up Kitematic, and that's the extent of my experience.
Cool. So obviously today's topic is going to be around Docker and Kubernetes. And, let's get a 30-second definition of Docker going here. What you got, Aaron?
So Docker is an image and a process, and it is completely isolated from the rest of your system via the Linux kernel. This is great because every time you hand out that image to anywhere else, it's the same image everywhere. So it's the same Docker container that you get to run everywhere, which helps make your infrastructure kind of agnostic, right? So as long as it can run that container, you have the same on your development, your test, your integration, your production, everything.
So it sounds like Docker is for ops people.
It is, but unless you are in a place where you're doing dev and then you just hand it over to somebody to do ops, you need to know how to do ops.
Yeah, we'll dive into that here in a minute. What about Kubernetes? Quick definition on this one.
Kubernetes is a tool to help you define what you want from your infrastructure, mainly what Docker containers and network resources you want, and have them automatically be applied and kept there. So if something dies, Kubernetes is responsible for restarting it, and it does that in an automatic fashion so that you always have either the same infrastructure or something that's getting close to the same infrastructure all the time to help you develop like HA apps and to basically run your Docker containers in a sane fashion.
So, okay, let's talk about those containers. And you mentioned images. What kind of images are there? Is this so? I know personally that I can use Microsoft SQL Server 2017 on Linux with Docker. What kind of other images are there?
So, an image is realistically, it's a little different now that they have Windows images. But at the beginning, it was a file system that is compatible with Linux, and you tell it what program to run within that file system. And that's an image at its base and heart, right? And that helps you take that image and transplant it other places that also have it. So for the longest time, Docker on Mac and Docker on Windows actually spun up a VM that you would run the Linux image. It's a little bit different now that you have Windows and native Docker on the different platforms, but at the heart of it, it's still the same. You have an image with everything.
So real quick, let's back up a little bit because we're talking about these images. It's probably worth knowing Windows versus Linux images, what's the same and what's different about them. And when we talk about images, when you hear about Docker, there's really two things that you hear about. There's images and containers. So let's talk about the difference between Windows and Linux, and then let's talk about what the difference between an image and a container is.
Okay. So I'm not as well versed on Windows containers because I haven't used Windows for anything but gaming for a very long time. So I'm not going to say that I'm 100% on this, but with those qualifiers out of the way, the concept is still the same. It is an isolated process, and the key there that I say is it's a process. When that one process starts up, once it's dead, the container is closed. But it's an isolated process with a isolated file system that you can move that bundle around to anywhere that has Docker, and it should run just no problem, right?
So I don't know if anybody else wants to jump in here. Like, one of the big differences with the Windows versus the Linux ones are Windows only run on Windows, right? Like Windows containers will only run on a Windows platform, whereas there's been headway made into the Linux containers or images to where they can run on Windows or Linux or several other platforms. So
yeah, I can shed a little bit of light on this. So without digging super deeply into the really, really low level, like kernel resource sharing technologies that are different between Linux containers and Windows containers, the main difference, aside from the fact that Windows containers run on Windows and that sort of thing, is that Windows containers, unlike Linux containers, have two different isolation modes they can run in. Mm-hmm. So when you run a Linux container, there's only one isolation mode. It runs on the host in a manner that's visible to the host. So it's running on the host's kernel as a process visible to the host. Windows containers work that same way by default, but there's also a slightly more isolated mode where they run as Hyper-V containers, which is where Windows will actually spin up a super thin virtual machine, which has its own kernel that's not visible to the host operating system, and then run a Windows container inside of that. So they're even more isolated than a Linux container would be when they're run in that mode.
That's excellent information. And the big part that I think is important to know is some people hear Docker, they're like, oh, I could just go run everything, right? And it's not, right? If you're on Windows and you want to run Windows containers, you have to be on Windows. However, if you want to run Linux containers, you've been looking at the latest Elasticsearch or something out there, you can do that. So,
yeah. Do we want to back up a little bit and really more specifically define what a container is compared to what we're familiar with? Because, I like to start out by saying that a container is just like a virtual machine, except for every single thing about how it works. So conceptually, it's very similar. It's a way of isolating, usually, as a software developer, you're running application in its own environment that's not actually a physical machine. It's a virtual machine. But the difference between a virtual machine and a container is everything going on below the surface. So with the virtual machine, like a hypervisor-based virtual machine that most people are familiar with, your virtual machine has an operating system on it that sits on top of the host's operating system. So your computer might be running Windows, and then your virtual machine might be running Linux. So you have a Windows kernel on your host operating system running a hypervisor, which has a virtual machine that then has a running version of Linux on it with its own Linux kernel. And then your app sits on that.
With the full-blown OS, right?
The full-blown thing. So like a virtual machine is going to be gigabytes in size.
Right.
And then with a container, there is no host operating system inside of a container. The only thing a container is isolating is the user space, which is, let me look back at my notes here. So as if you were running an operating system, you get your own root file system, process tree, and networking stack, but it's actually being virtualized by sharing your host operating system's kernel and not by installing a whole other kernel on top of it inside of an isolated container, which is a terrible word to use for this because we're calling it containers versus virtual
but the
machines.
key here is it's super lightweight, right? Because it's running as a process in your host operating system as opposed to running an entire OS inside your host.
It's super lightweight and super fast because it runs as a process on your host kernel.
Yeah,
there's also the resource constraints though at the hardware level too that we've talked about before, where like in a virtual machine, if you wanted to have a VM with 1 gig of RAM, for example, and then every time you spin that virtual machine up, it's going to take up 1 gig even if you're not using it. So if you spun up 100 instances of that VM, you would need 100 gigs of RAM for that plus whatever the host OS needed. Whereas if you created a Docker image that used say a 1 gig of RAM, it's only going to take that 1 gig of RAM if it actually used it. Otherwise, it's not. So if you spun up 100 instances of that Docker image, then you might not necessarily have 100 gigs of RAM in actual use or held.
So what you just stumbled on there is one of the biggest benefits of containers, in that most of the time the apps that you write don't use all of the resources of whatever process container it uses, right?
You've never seen me write my apps, have you?
Probably not. But most apps, right? And the idea here is that your containers kind of scale with what's demanded of it versus a virtual machine has to be pre-provisioned and will have waste. So that's one of the big fundamental shifts in operational support with Docker, is that, yeah, I have 10,000 apps running on this one machine, but they're all like apps that are mostly sleeping and take 10 megabytes of memory. So who cares, right?
Yeah, and there's a lot of sort of magic in the layered file system, which is what containers run on top of and what images are built from that make them so lightweight and efficient. I don't know if we wanted to go into how that works at all.
So I think you touched on the next point that we want to talk about. What's the difference between a container and an image?
Yeah, so I can take stab at this one, Aaron.
Go for it.
Okay. So at sort of a high level, an image is basically, you can think of it as a compiled application. A container is a running instance of that application. Now, they're not actually applications. To be more specific, images are built on a technology called a layered file system. And the basic idea is that when you're creating a Docker image, you create a Docker file, which is just a text file that's basically the closest thing to a list in plain English as far as languages are concerned. So each line of your Docker file is an instruction. And what happens is those instructions in your Docker file get executed top to bottom. And each time an instruction is executed, something is happening to change the state of your file system to make it make the changes per the instruction. And then the difference between the previous state of the file system and the new state of the file system is actually stored on disk as a file. And that is one of the layers in the layered file system. So basically, a Docker image is a bunch of layers containing changes to the file system that are packaged up together. And the last thing you do with a Docker file, almost always, is you define the command to be executed when you start the container. So you basically have a precompiled state of a file system with a command preloaded into it as to what to do when you start it. So then when you turn an image and you run it and turn it into a container, that entry point command that you define gets executed. It becomes process ID 1 inside the virtual process tree. And the container will stay running as long as process ID 1 is running. And it stops when it's not. And that's really all a container is.
One thing I thought was really cool is that a lot of people have actually set up images that just run a single command, like curl or something. So you can actually just like run a command that you wouldn't normally be able to, or run something very specific and lightweight, like just really easily. And so that kind of is like, seeing stuff like that kind of got me thinking that like maybe Docker isn't so much just for ops. It's also really developer friendly. So I've used it for a couple little things here and there that have made my life a lot easier as a developer, but I'm really missing that kind of deployment piece. But I still feel like I'm getting a lot of value out of Docker.
Yeah. And one of the other cool things about the way this layered file system works, just to sort of explain, why I went into all that detail, is because one of the advantages we always talk about is how lightweight and easy to share Docker containers are. And the fact that the images are built on top of file system layers is what enables that to happen. So when it's building these layers to make an image, every instruction is executed, turned into a layer on the file system and stored, but it's tagged with a hash. So it has a unique name, and that allows it to basically reuse every single layer from an image and only have to build it once. So even if you're building two completely different Docker images, if the first 5 instructions start from the same place and end in the same place, all 5 of those layers will only exist on your file system once. So it's not like a virtual machine where if you want a copy of the virtual machine, you actually have to copy, all 6 gigabytes of the operating system, the app, and everything in between. It's like your Docker container may only be a few hundred megabytes, but the first 200 megabytes of that are actually shared between every single running instance of your container.
Hey, so to kind of give a little example of what he's talking about, because this is really important. This is really one of the cool parts about Docker is when he's talking about the layers, like in a Docker file, he said, there's commands that happen. And if you think about a simple Linux type thing, and I'm going to go with Linux because this is more common procedure in Linux. Let's say that you start off with a base image of Alpine, which is a very popular Linux Docker image because it's super lightweight. Typically what you want to do is if you want to install Vim on this container, you're going to do an apt-get update, right? So you're going to say run apt-get update. If you have a single run statement for that, that's going to create a layer because now that is part of what you appended to this base file system that he's talking about. Then if your next one is apt-get install Vim, then that's a second layer that it's going to save in the Docker file. And then if you do something after that, like, clean up, like I can't think of the command to actually get rid of all your apt-get updates and all that kind of stuff. Every one of those is going to add another file system layer. And if you were to inspect that container or that image after it's all done, you'd see those hashes for every single one of those commands. And you could actually go look at what the command was that built that layer. And so that's what he's talking about. Every single thing that you do builds up this image so that you can almost reverse engineer this thing and go back and look. And it's worth mentioning also, there's also tricks to get around this so that, this whole apt-get update, then apt-get install and all that kind of stuff. A lot of times you want to keep your images really lightweight. And so instead of having those as separate one-liners, you'll have like an apt-get update, and then you do an ampersand, come down to the next line, and then do the next command that you want to run. And then that way you only get one layer. So it's basically a layer per command that you run. So if you call run 10 times in a row, that's 10 layers. However, if you call run and then you separate it with ampersands at the end and then just keep appending on additional commands, you only get one layer in that file system, which keeps it really light.
That's a great segue into multistage builds.
Where I was going with it too.
All right, so before we jump into those, let's give Nick a chance to introduce himself. He just jumped on. Nick, can you give us a 30-second introduction to Nick and then what your experience is with Docker and Kubernetes?
Cool. Hi, can everyone hear me?
Yes.
Cool, great. Sorry for being late, playing good to sleep. I'm a contractor, Python developer mainly. I've worked with Docker for the last 2 years and Kubernetes quite intensively for the last year or so. I've built multiple startup infrastructures based on Docker and Kubernetes, and it's something I almost insist on nowadays if I can, since I move into a place. So yeah, I like to think I've done a fair amount of it. Not as experienced as some, but awesome. I know my way around it.
Excellent. Well, welcome.
And hey, you put together Coding Bot or Blockspot, right?
Yeah, I did. And he's on Docker. He's a Docker image as well. So he's running off of that. Not Kubernetes, but it's only a single container, so no point.
Okay, so let's go into back on track. Multi-stage builds. How do those work?
I'll run with this. So multi-stage builds are, you have that layered file system, and to start it off, you have a from line, and then what you do is you put another from line and then another set of builds. And what happens is there's first a build of that very first container like it would normally be. And then when it hits that from line, it starts a new container from whatever your base file system is, and you can basically copy stuff from the first build that you were doing so that you can have an even leaner container. And I'll give an example of this. I work a lot in Go. There's half a dozen commands that you end up running, like your test, your vet, build, and it comes and spits out a binary, which is great. I then just copy that one binary, because that's everything that I need, into a new Alpine image, and my images are basically 5 megabytes plus the size of the binary, and I don't have to have the whole source tree for everything that I built and everything. But the output Docker container is just a super tiny thing that is only exactly what I need to run what all my code is.
So those from statements, what you were saying though, is you were building from a previously built container, from the next built container, from whatever. So basically you're saying, hey, use these other things that I've already built and then create this new one.
Yeah. So example would be from Alpine Golang, and it would have all the stuff to build stuff, and then just a from Alpine, and it says copy from the first one, or just app, and then run app. Right.
Yeah.
Is it like having an SDK image to build all of your code that's not yet compiled, and then a separate runtime image to actually run just the bits? So that makes it much lighter weight.
That used to be a common practice, actually, where you'd have a dev Docker file and then a production Docker file, basically. So I think it's important to understand for realizing the power of multi-stage builds is that before multi-stage builds existed, it's always been true that every Docker file had to start with a from statement. You have to start with some state, and it's usually just some flavor of Linux. And then you would say, step 1, move my source code into this image. Step 2, compile my source code. Step 3, actually execute it, set the entry point command. But you don't actually need the source code still in the container when you're running it. So you might want to have an intermediate step where you delete the source code and just keep the compiled binaries around. And before, that basically was very difficult to do. With multi-stage builds, you can start from essentially a blank slate, load your source code on there, compile it, and then delete that, basically the source code, and just leave the compiled binaries. And you can tag that state as basically a new from statement and say, okay, we started from Linux, we had my source code, we compiled it, we deleted the source code. Now we're going to tag this as, compiled. And then you can start what looks like a new Docker file just on the next line and say, from compiled, set the entry point to start the app. And then your actual Docker image will throw away everything from before that last from statement. So you'll only end up with the compiled binaries and entry point command on your final image. It'll be much smaller.
Real quick, you brought up another thing that I don't think we have in the notes is this whole concept of tagging. I think it's worth bringing that up because when you're working in source control, you'll typically tag something, right? If you reach a complete state or something, you'll tag it as whatever the version is or that kind of thing, right? Tagging in Docker is interesting. It's cool and it's frustrating, right? So there's this notion that you can tag something of a particular version, let's say 1.0, right? And you can name it whatever you want. You can tag it with, my name is Paul, if you want to do that, or you can give it a version number. But they also have this notion of a tag that's called latest that is sort of a moving target, right? So if you tag something latest, you could be getting version 1 or you could be getting version 5, depending on where it moves. So when working with containers, or images, it's probably worth knowing that, because if you're targeting something that you want to work, you probably want to include the tag that you're actually trying to use. Otherwise, it can move on you and break everything. You don't even realize it.
So
yes, the latest tag is not really a tag because it's always moving.
Right.
Yeah. The important disclaimer is that if your from statement doesn't explicitly include a tag, it will implicitly go with latest. So, for actual, doing work purposes, just like, with your JavaScript package managers and whatnot, you want to explicitly define your version and not just let it auto pull the latest all the time.
Yeah,
right.
In your versions.
We use latest extensively at work, but mainly for staging builds, basically. So for us, it tracks master branch. Right?
Yeah, and it's probably more safe if you're talking about your own Docker images than, a third party as well.
Right.
So then, okay, so let's jump into this then. How easy is it to get started with Docker? Is this something that I need to sit down with, my ops guy, sit down with our boss and say, okay, we're changing everything we're doing right now. We're going to a fully containerized environment. Or can I incrementally do this? And then what sort of value does this provide?
So I'll start off with this, but I don't think it's generally a good idea to say, let's just convert everything that we have to Docker right now.
Buzzkill.
I know. I feel that because there's a lot of risk in there, and you don't get the payoff that you get from Docker until you have a Dockerized app. And and really what it comes down to is there's a lot of legacy applications that aren't built with the constraints that Docker has, so they won't work well in Docker. It's not that they couldn't be made to work in Docker, it's just how they are now won't work well. So it's much better to take incremental pieces and define where you are, but it's also good to have some time set aside at the very beginning to say, this is how we think we want to do Docker and how we want to deploy it and how we want to have it updated and maintained. And yes, if you have a dedicated ops team, that's going to take a lot of time and that's going to take a lot of effort, but the payoff ends up in faster dev cycles, smaller applications, and moving your applications more to a more maintainable state than if you were to say, I now have this production database, it's now sitting in a Docker container. Go.
Right.
I want to expand on that a little bit though too, because which you kind of hinted at, but it's going to vary case by case because some parts of your overall application may not flat out and support it at all. So it might not even be an option to go 100% Docker.
Oh, okay. Yeah, that's good to know.
And the nice thing is Docker does play well with legacy apps, right? It still has a network stack. You got to expose it a little bit weird, but you can do it, and it can talk to things that aren't inside of Docker.
Yeah, I think one of the advantages of even just as an exercise of trying to move a legacy app into a Docker container, even if you don't run it that way in production, going through that process will really force you to very explicitly document every single thing that you've tweaked about the environment in which your app runs, because you have to lay it all out in a set of instructions in your Docker file. And a lot of times, some of the reasons why these migrations are so difficult is just because you don't actually understand all the changes you've made to your environment because they've happened slowly over years. You have some service running that does something, you've changed directories around, permissions are weird. All those little things that you've done that you may not realize or have documented, you have to have that because you don't get to just log into your box and click around and change things to try to match the state of your environment. You have to just write it down in a list of steps.
So it sounds like I can incrementally implement this. Is this something that I could do in like my dev workflow and not be disruptive to the team?
I definitely think that's the way to go. Like from the beginning, my first port of advice is normally find a service that you depend on that's not your own service, like Redis or even Postgres if you want, and run that in a Docker container. That's usually really easy to do and gets you into the flow of running stuff. After that, try find parts of the application you can Dockerize, play around with building a Docker file, and see if you can get it running. But do it in your dev workflow. Once you've done it for yourself, you can easily give it to everyone else.
And you know what I love about that is if you do it that way, it's not disruptive to the rest of the team, like you were saying, Sean. But here's the really cool part is if you do it in your dev workflow, and let's say that you commit that to your repository, your Docker file, your Docker file, and you actually put your images in a repo that people can access, then other developers can start to use that. Because right now, for instance, what Sean was saying is when you start documenting your environment, I mean, we've all seen this. Every dev shop you've ever been at, you'll have some sort of wiki or document that's like, here's how you get the application set up, right? And then 2 hours later, you've got something running.
That's a good one. If you got it in 2 hours, that's good.
Right. Well, I mean, the skilled of us could do that. So, so then though, if you take this, the next step though, which is really cool, is, and Joe did it with QIT, and we've done it with many things, is if you get that Docker image built and you have a repo, the next person that comes behind you can just do Docker run my app, and you're literally up and running, depending on the pieces that you've got, or those pieces, in seconds, as opposed to hours of going through this thing. The downside to it that I've heard people point out in the past is then you're not as intimately familiar with the entire stack. But the cool part is you can go look at that Docker file and you can see exactly what was done step by step. It's almost self-documenting, and it's like good code.
So to summarize what you're saying then, the advantage here is by using Docker and the Docker files, you're treating your infrastructure as code that can be committed and shared, and you can see a history of what was happening there, versus some random Linux server that you have sitting in a closet, and Joe happens to log in and change configuration, and I'm like, oh, when did he schmod that? I didn't know that was changed, or
Yep.
Joe.
Yeah, I want to say too, speaking of history, Vlados actually set up all the Docker images for QIT and did an amazing job. But I wanted to point out too that, like, even if I were to go back, kind of like rewind in time, or just fast forward, and I was working in a small boutique web shop, I think I would be looking at Docker as a developer. Even if I was standing up like WordPress sites, it seems like a really nice way to kind of keep everything in one little tidy box. So if I've got 3 or 4 clients on different WordPress versions, or Django or whatever, I don't have to worry about those environments kind of mingling and getting weird. And then I can just kind of take that container and theoretically just ship it up to wherever it's hosted. I've kind of run into some friction with that actual, like, the ease of taking that container and just kind of slopping it up somewhere. But I'm still trying to wrap my head around that part of it.
Yeah, likewise for me, I've found products which I couldn't even build on my computer. They wouldn't run. I was missing libraries. I was missing drivers. I'd have to change my machine itself to get it working. And you just put a Docker container on instead, and it's working like that. No need to change my own setup.
I've worked on projects where it was literally a month rebuild process to get all of the DLLs because, the developer that originally did it left, and I'm like, okay, let's try and find this DLL. What's this DLL? And I'm contacting vendors. And so you're telling me that I can put all that in source control and make my life easier, and also everybody on my team's life easier.
Definitely.
So this is something that we should, as developers, we should be investing in this because it makes our jobs better. Our quality of life goes up with this. This isn't just like the latest fad.
Agreed.
This isn't just the latest fad. And my comment at the very beginning, where everybody is ops, it's this. You still have to consider all of the different bits and pieces and what's on your machine, where it is. Even if you're just writing an application, that's not just an application. So it behooves you to be able to have a shareable interchange format for actually running applications, more than just, hey, here's a binary and it needs 18 different DLLs and 3 different services running alongside of it.
Yeah. So there's a whole family of questions that are related to what comes next, because we talked a lot about what Docker is, how to use it locally as a developer. So it's pretty straightforward to just take one app, put it in a container, and run it as one container. So then the natural place to go from here is, how does any of this translate into, say, a production environment that lives outside of your local machine? Because real apps don't have just one service running in isolation. They'll have it probably at the very least multiple instances of that same service, if not multiple different services all talking to each other, and then redundancy within each one. So I know that there's tools like Docker Compose out there that let you sort of orchestrate some of that in a more crude fashion. But my understanding, which is very little, of Kubernetes, is that it is designed to solve that entire suite of questions that I have that comes next. How do I do this in production?
Okay, Paul, let me bring you into the light and show you the way of Kubernetes. And I say that jokingly because for some people it is almost the religion of Kubernetes. But so what Kubernetes is at its base is a platform for you to take Docker images and tell Kubernetes in a YAML file that I want 5 of these ones and 10 of these ones and 3 of these ones, and oh yeah, you have like 30 nodes over here. Go run and make sure there's always 5 of these and 10 of these and 8 of these, right? Always, just always. And Kubernetes goes and helps figure that out and make sure they're running and tries to spread them out and has resource constraints and all sorts of cool features to make sure that your application has the resources it needs, but at the same time also has the number of containers running that you need, not necessarily your application needs, but you need.
Yeah. So at a really high level, like my perception of Kubernetes is that it's at least one level of abstraction on top of everything about Docker, where I will define the entire end state of my whole infrastructure in some sort of Kubernetes markup language file, which is what YAML is that you mentioned.
Yeah.
And then I will hook Kubernetes up to one or more cloud providers. And then via black magic, Kubernetes will just make my desired environment exist and stay in that state.
So at a high level, yeah.
But it doesn't use black magic?
It does,
Sometimes.
The kubelet. No, so there's a lot of different pieces that I was trying to gloss over, but the idea here is there's a master a set of masters that you talk to, and these can be any computers that you want. If you go and look at Google, Azure, or Amazon, they all have a managed Kubernetes service, and essentially what that does is they run the masters for you, and then you use that. And you say, okay, I then have these computers, these nodes, which are EC2 instances or Google Compute instances that I want to associate with these masters. And then the masters go, okay, I now know of these 5 computers. I can run Docker containers on those computers. And then you say, here's what my infrastructure should look like. I need 10 Docker containers of various size and width and dimension and these images. And it goes and says, well, I have 5 nodes, so I'll put one on there, one on there, one on there, one on there. Oh, well, one on there, one on there, one on there, one on there. Okay, we got 10 of them running. We're good, right? So that's kind of like the workflow of what Kubernetes does. It does a lot of other black magic too. But I want to call out 2 things. First off, it doesn't have to be in the cloud. If you wanted to take 10 computers and make your own Kubernetes cluster on your rack, you are 100% able to do that. And it's actually not that hard. There's a couple of tools to help you do that.
So that's actually exactly what I wanted to ask. So I just got my head wrapped around Docker and how amazing it is, and like, okay, I'm sold on Docker. Do I now need to learn Kubernetes as well just to get all of this running in production? Is that a whole nother tech stack that I have to convince my team on and my bosses on and all that?
No, not really straight away in my opinion. But as soon as you want to scale, as soon as you want a single service to scale across multiple nodes, I would say Kubernetes is what you want to go to.
Can I back up 1 minute? I just want to make sure, because of this, I want to make sure that I understand this right and make sure I understand its place in this overall world, right? But so we started with Docker, right? So you could build one container and you could run it someplace. And then Docker Compose was briefly mentioned a few minutes ago, which my understanding of Docker Compose is if you wanted to have multiple containers spun up at the same time, then that thing would do that, but that's all on the same host. Where Docker Swarm or Kubernetes come in is when you want to do that orchestration across multiple machines. So you might want multiple containers spun up, but not all on the same host.
Yeah, exactly that.
So there is a little bit difference of opinion on what Swarm's idea of orchestration is versus Kubernetes.
By orchestration, you just mean do the thing, make everything work for me.
Yeah, so exactly. By Swarm, you tell it what it wants. It does its best effort to make sure that all of those are there, and then it provides a platform for you to continue to do that. Kubernetes, on the other hand, says, you told me what it is, and I will continually try and make sure that it stays that way. So if one of your Docker containers dies, I'll start another one immediately. If a node just disappears and I can't talk to it, I'll take whatever was running on that node and try and spread it out amongst whatever's left, right? Those primitives aren't all present in Swarm because they have a slightly different way of talking about what orchestration is.
Okay, so real quick, I want to back up here because we talked about spinning up multiple nodes and containers and all that kind of stuff. I think it's important to know, though, that the natural evolution of somebody learning Docker, and this is where the frustration will set in, is you set up your container, or you grabbed an image, you have this cool image, and you've got this container, and now you're like, okay, well, now I've built my app and it's running in a container, but it needs to talk to a database, right? And I'd like to put my database in a container as well, but how do I do that? Because the thing is, when you're working in Docker, it's all very manual at that point, because you're like, hey, I got my app over here in this container. Now I've got my database in a container. But how do I know when my database is ready for my app to start using the database, right? That's the other answer that Kubernetes and Docker Compose and all those things do for you, is they have these dependency trees built in, right? So that if you go to, we talked about creating these multiple containers, but it's important to know that they also know about dependencies, right? So if you start up your app, what you can do is you can say, my app has a dependency on my database server. My app also has a dependency on these 5 services I created, right? And these are all going to run as separate containers. And that's part of what this whole orchestration is not just spinning up the containers, but also letting the other containers know when these various different services are ready so that your app is in a good running state.
So I'm going to pull the e-brake on us real quick and take us in a different direction. You just said you want to be able to put your database in a container. So to me, and I could be way off base here, containers seem like something that you can ship and move around and all that. How do you handle the persistence with your database? How do
That's a good question.
Yeah, maybe this is in the notes already, and I don't have that, but that seems like, to me, that's a big red flag. I'm going, wait, hold on. I don't want my database to be shipped around and moved.
We did not cover that, but that's an excellent question. When you're defining a Docker image, one of the things you could do is mount a volume to it, and there's a number of different ways you could do that, but it's very conceptually similar to what you're probably familiar with from setting up a virtual machine, where you can share space on the host's file system with a container. And also, when you were talking about talking to a database from your containerized app, another thing to call out is that containers by default are completely isolated from the outside world. There's no, internet into them, even if your host that you're running the Docker container on is exposed to the internet. You have to explicitly map every port into and out of all of your containers. Even if you just have one container running your service and your database lives elsewhere, you have to tell your container specifically that it should be exposed on some port. And then you also have to tell the Docker host explicitly when you run your container that it should map its port to the internal port that you just exposed on your container. Otherwise, a containerized app running has no access to anything.
And for the most part, you would just have the database service as a container that works with a volume that's the data file for the database?
Yeah, so that's typically what you do. So what he was talking about, mapping a volume, and think about it like almost like a shared drive, right? Or a shared folder that you can access from somewhere else. When you define that Docker container, you tell it that you're allowed to mount to this particular folder, right? And then when you start up that container, you'll point it at where that location is. So if you do have a database that you want to persist, this kind of hits on something that's really interesting. If you have a database that you want to persist, then you'd map that volume in. But let's say for testing purposes, you want a database that you can run some testing against. So
I want to full stack that I want to run full end-to-end integration tests.
If you want to do that, then this is a perfect example of where you'd have a database that you can literally spin up, run your test, make sure everything's in a good state, blow it away. And then the next time you start it up, you have a database in that same exact starting position so that you can go through and run them. But if you have something
baked into the image, running, not where you use the shared volume, but you bake the database in.
Yeah.
Right.
Okay. So then, all right. So just to do a quick recap, get us back on course. Sorry, ripped the e-break there. We have Docker, which has containers and images, and that's how we isolate our runtime environments or our development environments for our application or our database, what have you, whatever it is that you want to isolate. You can Docker compose those and create multiple running versions.
Different services running all at once to create the one service that you want to expose.
Perfect. So I have an app server, a database server, I Docker compose, those both get spun up, and we're good.
Yes.
So
All on
then,
the same server, but yeah.
so then it gets more complicated than that, right? This is where we're getting into different orchestration techniques, Docker Swarm, Kubernetes. So let's get back on with Kubernetes.
Yeah. So to really sort of understand the power of something like Kubernetes, I like to kind of walk through all the questions you might ask, starting from just one container. So the first thing, after you have one app running in one container by itself, you might say, okay, how do I make a more complicated app that has two or more services that can talk to each other? They have to run at the same time. They have to have network lanes open between them so they can communicate. That's where something like Docker Compose comes in as the logical next step. You define in a file up front the entire state of your cluster of containers. You say, I want one instance of server A, one instance of service B, one instance of service C. They all need to exist on this network. They need to have these ports open so they can talk to each other. And then you start asking yourself questions like, well, what do I do? Yeah, go ahead.
Just to keep that real simple, I like concrete examples here.
Mm-hmm.
We're just talking something like my web app and my database, right?
Exactly. You could have a web API server and then a single page app front end just running a static content on something like Nginx.
Now, does Kubernetes augment Docker Compose or does it replace it?
Replaces it.
It replaces it. Docker Compose is a tool for helping you think about Docker. And then Docker was building the tool Swarm, which they've kind of pivoted into Kubernetes. I believe there are some tools to help you transform a Compose file into Kubernetes resources, but I've not tried them myself, so your mileage may vary.
I've tried it.
Yeah. So I think to finish my thought, we can talk about where Docker Compose falls short, because we said, Docker Compose lets you define a multi-container application, how, what the services are called, how they talk to each other. But then you start asking yourself questions of, what if service B goes down? I need to make a new, I need a new running instance of service B. I need to discover that service and know that it is up and running and ready to be added to my application. I need to actually add it to my network, open up the ports. I need to do any necessary configuration, pass in environment variables, because we're not hard coding secrets into our source code, are we? So there's a whole slew of questions.
I would.
Exactly. The minute something goes down in a Docker Compose environment, you are 100% manual from there as far as recovery goes. And that's where Kubernetes comes in, and that's where I'm out of my depth talking about it. So I'm going to let Aaron
So this isn't Docker versus Kubernetes. This is how you use Docker with Kubernetes.
Yeah, so Kubernetes under the hood can use a number of container engines, Docker being probably the most popular. So once you've created those images and you've thought about how you want to compose them with your Docker Compose, you almost have a very similar one-to-one relationship with Kubernetes, in that you say, I need 3 instances of my API server so that it's highly available. And I want you to say, spread them out amongst as many hosts as possible so that you don't have 3 instances running on just one, so that if that node goes down, then all my API servers go down. And I want to do the same thing with my database. But, oh, wait, my database is a little bit different for HA. I can't just have 3 copies of it running. It doesn't work that way. I have to have like 1 copy here, which is the master, and then these other 2 spin up later. And there's a different primitive for that. And then there's these network primitives where you say, by default, the pods can talk to each other based on what their service name is. But say I need to expose the API to the world. Well, I just say add a load balancer, and that load balancer should point to this deployment. And Kubernetes will go and hook all of that up in a fairly high availability way. And this gives you the language to talk about multiple containers, multiple instances of containers, and multiple containers working together to provide a highly available, scalable app. Because say your API service is starting to get hammered. Well, all you do is you make a change of 3 instances to 7, and you've now more than doubled your capacity to handle API requests, right? Oh, your database is falling behind. Well, this is going to be a little bit of a manual step because you have to kind of copy it over, but you say, hey, I want to stand up a new master in a bigger instance, and that will span that up. And then you change you flop the actual database, that the volume mount from one instance to the other, and then you get going with it, right?
Hey, so 2 things then. One, it sounds like what we mentioned with Docker Compose, which, like I said, is like the natural progression, as Paul even pointed out. Docker Compose is like the next thing you go to because it's like, okay, now I have multiple things that need to work together, right? It sounds like Kubernetes is the next evolution, and that is, okay, well, we've defined what makes my application, but now I want to make it, like you said, HA, highly available, right? I want to make this thing to where it scales to where I don't have downtime and all that kind of stuff. And that's where Kubernetes starts coming into play is, how do I spread this thing out now? I know what all the dependencies are, but how do I make this where it grows everywhere?
Yeah. Go ahead.
And then, Nick, you said you had some experience with, I'm guessing, Compose is what it's called, the thing where it'll take Docker Compose files and turn it into Kubernetes. You want to talk about that?
Okay. The thing for me is if you try to use that service, I've only tried to do it once, and I gave up quite soon after. I mean, fair play to them, they tried. But the problem is it really shows what's different between Compose and Kubernetes. Because you put a Compose file through, you try to turn it into a Kubernetes resource file, and there's just so much missing.
Okay.
Right? It'll do some stuff. It'll tell you what the container is. It might give you the number of pods you're going to bring up and stuff. But there's a lot of things around secrets, environmental variables, and various things that you can do in Kubernetes that you can't do as well in Compose. That just won't get translated across. So it'll give you a partial file, but you're not going to get the service you want. More to the point, I mean, we're talking a lot about scaling. We're talking a lot about saying we can bring up more nodes and more instances across the Kubernetes cluster. But that's scratching the surface and what Kubernetes can do. I mean, we're talking mainly about what you call like a deployment file right now, which is what defines how many a pod is a set of containers, right? It's what your service actually is. It's how many pods you're going to run and where you're going to be running. But then you've also got a service on top of that, which is how you cluster these pods together. You've got an ingress resource on top of that, which is how you expose this to the wider world. And where Compose is basically saying, I'm going to run these containers. I might add some volumes, and I'm going to expose this port. Kubernetes says, I'm going to run this many containers. I'm going to connect them to these other pods over here. I'm going to call them onto these services, limit the access to this other cluster over here. I'm going to put in several ingresses, which means that you can access it from 5 different URL endpoints and stuff like that. I mean, but for me, the latest evolution in Kubernetes for me has been, again, in our staging setup, where we basically have a system where every time you make a new branch in Git, you push it to master, you push it to GitHub, that sends up a hook. And what happens is we use a templating engine called Helm, which is an extension to Kubernetes, and it creates a whole new service for us. It brings up a database, it brings up a service, and it gives it a URL. So we normally have service.company.com. That's the URL you go for the main service. This will be experimentalbranch.service.company.com, which only we can access from inside the office, right? And now every single branch has a live testing website you can go to try out. That's something Compose could never do. and without extensive work using other solutions.
Yeah, I think what Compose is lacking is any concept of the phrase over time. So Docker answers the question, how do I run a service? Docker Compose answers the question, how do I run an application comprised of multiple services? Kubernetes answers the question of how do I run an application comprised of multiple services over time? Because Docker Compose can do a fine job of getting, 10 containers running and docking to each other. But when one of them goes down, or you need to scale something up or down, or just add something else to it, deploy a new version of your app, there are 100 questions that come up. And that's where the power of Kubernetes comes in. Service discovery, health checking, scaling, things that are really, really difficult to do manually.
Yeah, the only thing I don't like about Kubernetes that I mean, not that I really know enough to have a strong opinion, but I was really happy with like the development story around Docker, and so I was really happy I could build my images really easily. I can stand up stuff with Docker Compose. I could ship somebody like a repo and say, just clone this, and if you've got Docker, you Docker Compose up, and it's running, and it even pops the browser up, and it's perfect. And then I go to look at deployment, and it's like, okay, it's about to get weird, and I don't see a good path from like my Compose story that I'm kind of in love with up to this Kubernetes story, which is much more complicated, and it seems like it needs to be that way. But is there something in between?
About 6 months of pain.
Wait, isn't that for every step of the way? Right?
Yeah, basically. I would say about 6 months of pain for each step, followed by 6 months of just joy and love.
Elation. Yeah, totally.
Yeah, well, I mean, like, honestly, what you're talking about is how do I give something to somebody else so that they can have my whole production set up and running in their own environment. And that's not a question that most people answer ever, because we need to know how we can set it up for us. And I don't care I don't care if my copy team has a copy of it, because they should be using ours. We're the ones that are the source of knowledge for this. But also, like, Kubernetes was built with, like, there is a CI/CD pipeline somewhere, and you use it, because not using it means there is going to be divergence from what the code actually is, right? So a lot of the Kubernetes stories, I'm feeling that pain myself, is built around there is a pipeline for your code, and you know how to use it, and your pipeline is extensible enough that it can talk to Docker. And I'm in a shop right now that they're like, Docker? What's this? This is a thing that people use? I'm just going to go write some more Java.
Yeah, I think you're right to call out that Kubernetes can be a big hurdle sort of conceptually to wrap your head around. And I think the reason for that is because basically what Kubernetes is trying to do is to automate everything a whole operations team would do. And if you as a developer aren't intimately familiar with the challenges that they face, then there is a lot to digest. If all you know is how the code works and you don't know much about how the environment itself works and is maintained over time, and you're not familiar with the challenges of service discovery and health checking and load balancing, then there is a whole category of tech to learn before you can really understand the power of Kubernetes. But I think that's also what is so exciting about it, is that it empowers developers to, I don't want to annoy the operations people here, but it allows you to have the power to run an environment like that without knowing every single detail about how it works. But you still need to know the best practices, and you need to know what's going on.
Right. Well, you know how it's all hooked up, right? That's the key part.
Exactly.
As opposed to, this is running on box 3 over here, which is the typical infrastructure approach to all this stuff. So,
So it sounds like you can adopt Kubernetes. It's not as incremental. You need to make a more upfront, we're going to do Kubernetes and sit down and think about it. But you don't have to go the whole shebang with it, right? You can dive in as little or as much as you want, as long as it's Kubernetes. Is that correct?
That sounds about right. I'd say it's also very helpful to have somebody from a more operations heavy background to help you go through this process too.
Oh yeah. I mean, I'm sure we've all heard of DevOps and the merging of development and operations, and Kubernetes, like, so I've been working basically DevOps roles, if you want to call them that, for a while. And Kubernetes is really the evolution of the DevOps movement. Treat your infrastructure as code, because it needs to be documented in that way, and build your infrastructure from your code. Right? There was Ansible and Chef and Puppet and whatnot. And then for your VMs, and then we have Docker, and we're like, well, that's even closer to code. And it lets us developers think less about our infrastructure and more about what our app does. And Kubernetes is kind of the evolution of that. I can think even less about the infrastructure. I just say I need 3 of them, and I get 3 of them. I don't need to know the wiring and the bits and pieces of, like, where is it running on a node? I just say I need a node, or I need a node with the GPU.
Yeah, I got called a few weeks ago. Someone in my office said that I was the DevOps guy, which was news to me at the time. I never really planned on doing that, but it's the point. I got bored of dealing with servers and configuration and making sure everything lined up all the time. So I just ended up using Docker, and then I wanted to get things deployed properly across servers and scalable. So I ended up using Kubernetes, and it's just that push, as you say, to make it more like code, make it part of my development instead of a whole other operations gig.
So I'm the accidental DevOps is now the new accidental DBA, right? So
yeah.
Exactly. Oh yeah, he's the DBA. What? No, I just.
I want to tell you something. Fight back against any title that has DevOps. It does not exist. It is not a title. It is a process.
But you know what, though? That title does pay well. It's actually one of the more lucrative titles in development right now. So 2 things I want to bring up here real quick. I know we're getting close to wrapping up here. One is the cool part about the infrastructure with the nodes and all that stuff is, keep in mind what Nick just said a minute ago is so important about this, is he got tired of managing servers. And by that, he meant he got tired of making sure all those servers had all the dependencies they needed on it in order to run the applications. When you think about Kubernetes and Docker, you literally have a set of generic servers set up that all can run containers. And so those Docker containers and images can be put on any of them. And because that Docker container has everything it needs to run, it can be put on any of them and run, right? So that's key. The second thing, go ahead.
No, I just want to jump in there. So it's definitely easier with the cloud, but this is not something that you have to do as part of one of the major cloud hosters. You can do this on your own rack.
Yes.
Correct.
I mean, just in defense of the cloud, I don't think I really need to defend it, but my favorite party trick with Kubernetes, I normally install it with a service called Cops, which gives you some nice little defaults, but my favorite party trick when I'm showing it off is to take a node, usually the one that either holds the load balancer or holds the database, and just delete it. And 2 minutes later, everything's up and running and it's fine, and a new node spawned, and that's your 2 minutes of downtime because you deleted your database.
I want to go to the same kind of parties you're doing those party tricks at.
They're great parties.
Yeah. Alan, hit your second point. Sorry, I didn't mean to interrupt.
No, all good. So the second point, or not even point, the second question I want to ask all you guys is Docker production ready? Or is it Docker versus other containers, but is it production ready? Because, if you follow blogs and everything out there, some people be like, it's not. It is. We totally use it. Your thoughts?
You're asking the wrong question. Docker's definitely production ready. The question is, are you production ready?
Whoa.
Exactly, right?
Whoa.
That's what people are really feeling when they're scared of things like that.
Yeah, so the voices that I hear, Docker isn't production ready. These are the curmudgeons that have been doing Perl development for the last 15 years, and they were going to do Perl develop for the next 15 years, and nothing's going to change them.
Yeah. These are the Luddites still on VB6.
Yeah, I think one misconception is that something like Kubernetes, it doesn't eliminate the need for operations expertise. It just allows the people with that expertise to be much more powerful in their role and to abstract away a lot of the busy work and what we might call boilerplate.
Jessica, you said something. What was it?
Oh, or if you're a dev working with those type of people who are stuck in legacy.
Yeah.
Well, a lot of people are scared of it because it's like, oh, I'm going to lose my job, right? That's always the thing that you fight with development, right? We see it all the time is people are scared to take on new technology because they think that it makes their job obsolete, when in reality, all it does is changes their skill set, right? They become better, like Paul said, you become more powerful. Now, instead of having to deal with server patches, which, by the way, we didn't even mention, one of the cool parts about Docker is security's kind of baked into the OS. So as long as you're keeping the OS up to date, you can have 20 Docker containers and they get the benefits of that one host OS being patched, right? So, but yeah, I mean, this all sounds like super powerful stuff. And the production ready thing, I think, is key for people to understand. And I like the whole, maybe your app's not production ready. And I like that approach. I think that's a good answer.
Yeah, I do like your take, though, on not sort of like trying to hoard, institutional knowledge and be the only person that knows how to work on one part of the system. Because even outside of Docker and Kubernetes, that whole concept is just backwards. If you intentionally become the only person at your company that knows how to do something, you aren't becoming an invaluable asset. You're becoming a liability. It may take them a while to realize that, but you're not helping yourself in the long run.
You've just increased their bus factor.
Exactly.
Right.
You've just motivated them to get rid of you.
So you talked about ever-changing skill sets, right? So what does that mean for the future of Docker and Kubernetes? What does that look like in 3 years?
Like, is this it? Should I be investing in Docker?
Yeah, we're done. Pack it up, guys.
Yeah. Learn Kubernetes and you're set for life. And I say that in jest, but honestly, you will see Kubernetes for 5 to 10 years. At least.
Like 5 to 10 years is a long time in tech now.
It is, right? At that point, it's probably going to get long in the tooth, and there probably will be something better. But like, it's going to be the next Java of development, in that it will be around forever and it will be supportable for a very, very long time. And then something's going to replace it.
C#.
Well, keep in mind, right?
No, F#.
Hey, Jessica pointed this out in the chat. This has been around for over 10 years at Google. This is what Google used to orchestrate internal containers.
Yeah,
so
Borg before Kubernetes. Yeah.
Yeah. So, I mean, it's not like this fad. It's not a flash in the pan. It's in use in real, major scale operations. So chances are learning this. And by the way, I was at a Microsoft thing, and one of the guys giving the presentation that worked for Microsoft was like, look, man, if you don't know Kubernetes, learn it, because it's here to stay, right? Microsoft is embracing it for Azure. AWS has their own things. Obviously, Google Cloud's going to. So, yeah, man, if you plan on jumping into any of those things, it's a really smart idea to start picking up these skills.
What's the best way to? Sorry. Well, what's the best way to jump in and learn it?
So I've learned by fire, trial by fire. I jumped in and said, how do I stand up a Kubernetes cluster? And then how do I get my app running on it? And I felt that was very instructive, but there are a huge swath of tutorials on like, here's how you get this app running. Like it's usually a scheduling app or like a notebook app or something like that. But it takes you through like, here you build this simple Python container, and then you take that container and you add a database to it, and then you do these steps to stand up a cluster in Google Cloud or in AWS or Azure, and then you go from there and start using the Kubernetes to start building the different bits and pieces to actually get an app running in Kubernetes. And I think that's very instructive. But like, if you really want to internalize it, you got to work with it a lot, and encouraging the next greenfield project you work on to think about being Kubernetes and cloud, like microservice, app-driven first, is something that's very useful in that case, I think.
Hey, so Jessica, another one, I'll give a plug to what Joe and several people have worked on, the QIT thing. So that started out with a Docker thing, and Aaron's even helped out with the Kubernetes implementation there. So I would say, honestly, I mean, if you really want to get some hands-on experience and just sort of be able to peek at it in somewhat a simplified manner, that's probably a good place to just go look at what they did for the Docker files and the Kubernetes and all that, because it's not like it's at massive scale right now, so it's easy to kind of grok. So yeah, doing it is going to be the best thing. But I mean, there's tons of Pluralsight videos. If you're on LinkedIn Learning, which used to be Lynda, they've got a bunch of good stuff. And I'd imagine, I hope Nick and Aaron also have some resources out there that they can point us to.
Yeah, just a shameless plug. I've got a couple of blog posts coming. One covering Docker, one covering Kubernetes. So
cool.
Good to have us in.
I would say start small. Don't bite off more than you can chew. Don't start with Kubernetes. Start with just Docker and one service and locally. Make sure you keep your head above water and don't get too stuck in the implementation details. Make sure you're always going back to that high level and answering your own questions. How do I run this service? Okay, how do I give this running service exposure to the internet? How do I add another service to this app stack? How do I let them talk to each other? How do I let one of them have outside exposure but not the other one because it's private? And to just keep building like that, don't lose sight of the big picture, and the tool set will sort of naturally emerge as you build these levels of abstraction in your own understanding of the complete environment.
Well, I'm changing my the app that I'm working on right now. That's the rest of my day. I'm going to a Docker. I'm sold. I'm in.
All right.
You've seen the sign.
To get started with Kubernetes, does your entire stack need to be containerized? Or so like if you had a database server that was not containerized, you could still set up your Kubernetes configuration to be able
As a rule of thumb, my database is never in a container. There's some risk associated with it. I just want to avoid it. So I have hosted database.
It's actually pretty uncommon to run a database in a container.
Okay.
So wait, didn't we just say that we can do that?
You can. It's just that there's typically not much of a reason to do so.
Got it.
Yeah.
Just because you can doesn't mean you should.
Yeah. Exactly. Like you would have to get into the weeds on why you probably shouldn't do that. But usually, if there is the state of your system, don't put it in a container. Put it somewhere in a managed service.
But I can host my database engine in a container.
You totally can. You totally can. As a matter of fact, there's even articles from Microsoft that say that, hey, it's production ready. Do it.
Yeah.
But,
you can.
Yeah.
Okay.
Don't start
Okay.
there.
We'll see.
Don't start there.
Well, that's how I started. That's how I'm doing my dev. All my local dev is a database.
Oh, no, that's fine. Local dev is perfect for it. And it's actually, I love that because I don't have SQL Server services running on my computer, right? I can literally, if I want that stuff done, I can just turn off Docker and we're good. But your production ready stuff, you probably don't want your database running in a container.
Yeah.
SQL Server on Linux, I think they recommend a minimum of 4 gigs of RAM.
Just for that.
Postgres is like, you need nothing.
SQL Server in general, if you're not running with 8 gigs of RAM, you're doing something wrong.
Right. Agreed.
All right. Well, I think with that, let's wrap it up. So had a great talk about Docker and Kubernetes. It's really opened up my eyes. And so let's go through and we'll do alphabetical order again. If everyone wants to say their name and like where you can be reached, if you got like a blog or a Twitter or something.
I caught that, Joe. I caught that.
Yes.
Well played.
Don't turn around.
So, again, I'm Aaron Clawson. Find me Mad Viking God on the Slack and in a number of other places on GitHub. I don't have a blog, and I really should, but I don't have time to write right now.
All right. I'm Alan Underwood. You can find me on the Coding Block Slack or at the Alan U on Twitter.
I'm Jessica Groot. I'm on Twitter at Angry Zoot. I'm not really that angry. And I'm also on Slack as Angry Zoot.
All right. And I'm Joe Zack. And I guess you can find me at the Joe Zack on Twitter, but really just at Coding Blocks is the best way to get a hold of me. And I'm always bumming around somewhere.
I'm Michael Outlaw. You can find me on Twitter at IamWalto, which is Outlaw spelled backwards.
Oh.
Nice. I'm Nick Sawitsky. You can find me at ndevix on Twitter, ndevix on the Slack, ndevix on GitHub, or my name, nick.sawitsky.com online if you want.
I am Paul Spoon. You can find me in the Coding Blocks Slack channel as Spoonraker. I do have a blog. It's codewithspoon.com. I like to blog mostly about software architecture. And I promise if you go read my 3 blog posts, I might actually post more because I've done a bad job of keeping that cycle up.
I'm Russ Hammet. I do have a blog somewhere I haven't updated in forever. People click links and ads on there, then I guess maybe I'll start again. I'm Amarl Hammet on Twitter because someone stole Krittner, and they're private, so I can't message them. But yep.
I'm Sean Martz. I'm on the Coding Blocks Slack all the time, and I'm also on Twitter. It's confusing. It's the at Sean's hand. It's a terrible name. Just Coding Blocks Slack.
So with that, we've mentioned the Coding Blocks Slack a few times. So I wanted to mention that if you want to join, you can head to www.codingblocks.net/Slack and find out information there. And like I mentioned at the top of the show, you can find all kinds of great developer articles at www.codingblocks.net.
Hitting stop.
Yep, same.
We did it.
Very nice.